In chapter 15, we will be doing two things. We will be working with the rules of exponents, and we'll be working with operations on polynomials. The exponent rules are as follows. When we're multiplying exponentials with the same base, keep the base and add the powers. If we were dividing exponentials with the same base, you keep the base and subtract the powers. Numerator power minus denominator power. When we're raising an exponential to a power, we keep the base and multiply the powers. In the above example, which is just a multiplication of three monomials, we want to rearrange the product such that we group like bases together. So we have y times y, x cubed times x, z squared times z. If we use the multiplication rule, it says keep the base and add the powers, we get y squared, x to the fourth, z cubed. For this next problem, you notice we have a product divided by an exponential. So let's do the multiplication first. Y to the fourth times y to the fifth. They have the same base. We're going to keep the base and add the powers to get 9. Now, dividing y to the ninth by y squared, the bases are the same. So we're going to subtract the denominator power 2 from the numerator power 9, coming up with y to the 7th. Let's see. Let's work with negative exponents. When we have a base with a negative power, you want to reciprocate the base, and the power becomes the opposite. I'm rewriting this problem minus 2 to the minus 3y as minus 1 times 2 to the minus 3 times y. The base that we have that's raised to the negative power is 2. So we're going to reciprocate that base, putting it in the denominator, but we're raising it to the opposite power. To simplify this answer, we're going to have minus y over, we'll have minus y over 2 cubed, or equivalently minus y divided by 8. Let's take this one. We have a fraction raised to a positive power. Two ways of looking at this problem. Let's look at the method on the left. We're going to take each of the bases for the x and the y and raise it to the positive power 4. So we'll have 4 to the fourth times x to the fourth times y to the negative 8. Simplifying what 4 to the fourth is, we come up with 256 x to the fourth, y to the 8th. An alternative approach to this problem is not to raise to the fourth power first, but to move the exponential with the negative power from the denominator to the numerator. So that becomes 4x y squared. Now raising everything to the fourth power, we multiply the powers, so it's 4 to the fourth, x to the fourth, y to the 8th. Simplifying becomes 256 x to the fourth, y to the 8th. What if we have a fractional base raised to a negative power? Well, what we could do here is, as I said before, reciprocate the base, and then the power becomes the opposite. So we have a fractional exponential raised to a negative power. So we're going to reciprocate this fraction, becomes y to the fourth over 3 to the first understood, x squared, but the power becomes the opposite, plus 5. We're now going to raise each base to the fifth power. So we're multiplying these powers. So it's y to the 20th, 3 to the 5th, x to the 10th. Simplifying that denominator a little bit, we have y to the 20th over 243 x to the 10th.